Okay, we're going to be working on this lesson on the integration of the trig function. So to be able to integrate the trig functions, you need to have the formula sheet all the time next to you. So this is the formula sheet. This is a page of the formula sheet with integration of trig functions, and also you need the formula sheet for the trig identities, and we're going to see in a minute why you need them. So we'll do direct integration. So for example, integrating of sec 3x times tan 3x. So if you look into the integration, in the formula sheet, you will see when f dash to x is sec x tan x, mean f to x is sec x. Therefore, you're going to use that for the integration. So integration of sec 3x tan 3x is sec 3x, always the angle never change, divide by the differentiation of the angle, which is 3 plus c. So the next one is sine 12x, and the integration of sine, it's cosine. Negative sine is cosine, and we already have the negative, so we have the negative here and we have the sine over here. So therefore we're going to do cosine 12x. The angle never change. This 6 is a constant, so it does not change as well. Divide by the differentiation of the angle plus c. Now you can simplify, and that's why it's cosine 12x over 2 plus c is your answer. So we continue with this. Cosine 5x minus 7, to integration of the cosine is sine, so therefore a sine 5x minus 7. The angle never changes, very important. Divided by the differentiation of the angle, which is 5 plus c. So now this one here, you've got cosine minus sine, so you can integrate each one separately. So the integration of the cosine is sine, so it's sine 2x minus 1, divide by the differentiation of the angle, minus the integration of the negative sign is cosine, so that's why this becomes plus, so it's cosine 2x plus 1, divide by the differentiation of the angle, which is 2 plus c. So the angle does not change, it's always, the angle is the same, but you divide by the differentiation of that angle. Over here, as you know, that you can't have any but we don't have a power rule, a product rule, so therefore we're going to expand. So we're going to expand this one here. So we have cot square x minus cosec. I have spelled it wrong. And then we have plus. Okay, we'll do negative times negative, negative times positive, so it's negative cosec square x. And then we have this one here minus plus cot x cosec x. So cot square x minus cosec square x, if you look into the formula sheet on page 4 of the formula sheet where the trig identities are, you can see that there is a trig identity called cot square x, theta minus cosec square theta is equal to 1. So therefore we're going to replace those two by 1, and those two are like terms, so it's cosec cot plus cos minus cosec cot plus cosec cot can be simplified, so that's 4, you end up with this, and that's the integration of that in x plus c. The next one, sine square 4x. Now sine square, if you look into the integration in the trig in the integration of trig the trig functions, there is no sine square. So I can't directly integrate sine square. Therefore, I'm going to use the identities. So you can't. So in the identities, if you look into page 4 right at the bottom with the double angle identity, there is this identity here, cosec 2a, cosine 2a equal 1 minus 2 sine square a. So we're going to rearrange that. Divide by 2. Okay, and that's what I'm going to replace this integration sign with, because sine square is two functions, so we have to apply the chain rule, and there is no chain rule. There is a reverse chain rule. We're going to do it soon, but that's you can't do double functions in here. It needs to be direct integration. So therefore, when you have sine square, cosine square, when you have product in the trig, you need to use the trig identities to change them into other expressions to be integrated. So I'm going to rechange that. So instead of sine square, I'm going to put 1 minus cosine 2a over 2 dx. So I'm going to cancel these out. So I'll end up with 1 minus 2a dx. So now I can integrate this one, x minus the integration of cosine is sine 2x over 2 divided by the differentiation of the power and plus c, and that would be your final answer. So now we're going to do the integration of more trig expressions, but this time when we have product of two trigs. Remember, there is no product rule in the integration, so we need to change the product into addition, and that's why we're going to use the trig identities on page 4. So if you look the trig identities, there is that product change into sum in the top right corner on the trig identity page. So we're going to use cosine sine, and that would be the second one. So we have this identity, that's the one we're going to use, 2 cosine a sine b equal, and so on. So I'm going to change it. So a is 8x and b is 2x. So therefore, we're going to change that into 2. There is no 2 in here, so therefore I'm going to divide by 2, because remember the identity is actually has 2. So this one has no coefficient 2. That's why I have to divide by 2. I need to add that 2. I'll end up with 2. So I'll do 2. What is this? Okay, so that basically that's what we're trying to do. So by adding that 2 divided by 2 is 1. So by putting 2 divided by 2, I will end up having this 2 here. And that's why we have this half at the front. Just explaining where this half comes from. So now I'm going to rewrite it. So it's the first sine, adding the 2, which is 10x, minus sine, take away the 8 minus 2, which is 6x, dx. Now I can integrate the sine to cosine. So integration of sine, it's a negative sign, so there's no sign. So that's why we will do negative cosine 10x divided by 10. Negative and negative become positive. Cosine 6x divided by 6 plus c. You can simplify, you can leave it as it is. So we can see the integration in here. We have all the multiplication of two signs. So we're going to use this identity, 2 sine a sine b. Because I have 10, not 2, so I'm going to do 5, rewriting it as 2 sine x over 2 sine 5x over 2 dx. So now I'm ready to be integrating. Sorry, not integrating. I'm going to rewrite, substitute the identity. So it will be cosine ax, a minus b. So x over 2 minus 5 over 2. So that's why it's cosine negative 4x over 2 minus cosine 6x over 2 dx. And now simplifying this, give me cosine negative 2x minus cosine 3x dx. Now it's ready to be integrated. So the 5, open a bracket, cosine is sine, so sine negative 2x over 2 negative 2 minus sine 3x over 3 plus c. And we don't forget the 5 here at the front. Okay, the next question says show that sine square x equal x over 2 minus half sine 2x plus c. So as we said before, we can't integrate the sine square, so therefore we're gonna use this double identity, which is this one here, equal 1 minus 2 sine square a. You notice the sine square a appears in 3 different identities. The first identity is cosine square plus sine square equal 1, and that's not useful for us because if we replace it, we will get cosine squared. It's the same problem. And also there is another identity in the double angle. It says cosine 2a equal cosine square a minus sine square a, and this one also not useful because I have cosine square a. So I'm trying to get all the power. So therefore it's only this the identity we can use. So I'm going to rearrange this one here. So we will end up with sine square a, taking this to the other side, become 1 minus cosine 2a divided by 2. So now we're going to substitute it, 1 over 2 minus cosine 2 dx. Now integrating, so we'll end up with 2 minus cosine 2 x is sine 2x over 2 is here, multiplied by the differentiation of the angle is 2 plus c, 2 minus sine 2x over 4 plus c, and that's proven. Okay, so this one here is again multiplication between the two. So we have sine, so we're going to change it. Look, sine A, sine B, that's the one we're going to use. So therefore we're going to rewrite it as cosine 2x minus 2x. Okay, I'm going to write it in here, but you can do it always by hand, sorry, on the side, but I'm just going to write it in here. So it's 2x minus 1 minus 1 plus 2x, and then we have minus cosine, and add them together, give me 2x minus 1 plus 1 minus 2x dx. And now simplifying this, I got cosine 4x minus 2 minus cosine, that simplify, so 0 dx. And cosine 0, the value of cosine 0 is 1, so therefore I have cosine 4x minus 2 minus 1 dx. Now it will be cosine 4x minus 2 divided by 4 minus x plus c.